Hello, welcome to Governor Mifflin Coding Club. My name is Jim Hong. This video accompanies lesson number one, basic lesson number one, basic LED, and it's an introduction to coding. We'll be using an Arduino as our programming platform. That's an Arduino. In this lesson, you'll learn the basics of an Arduino. We'll learn how to create a basic sketch, build onto those basics, and at the end of the lesson you should be able to wire up LEDs onto a breadboard and onto the Arduino and program them to turn on and off. The objectives, again, is to understand basic circuit concepts, understanding LEDs, and basic programming of an Arduino. Let's get this out of the way here. Let me show you what an Arduino is and some important points to it. This is an Arduino, and get this in focus here. These are digital pins on this side, and they are either input or output pins, and there's a ground pin here, and then there's 13 pins going down. And again, that's all digital pins on this side. Analog pins are on this side, so if you have an analog device that you're putting input or output, again, these can be input or output, and you will declare that in our program. This can also be used as a digital pin too, but they're basically for analog. Your power rail, your power is coming off of this set of pins. There's a 5-volt output, and there's a 3.3 volt output and 2 ground pins on here. That's your power rail. This guy here is your processor. That's an ATmeg. It keeps going in out of focus. An ATmeg 328P, and that's your processor. That's actually your computer part. Your connection to a computer is this USB port here, and you would plug that into your computer so you can communicate back and forth with the Arduino. Once you have your program on the Arduino, this is an external power port where you would put power into the Arduino to keep your program running. So if you disconnected from your computer and wanted to keep that program on this Arduino running, you would put a power in here. That'll take, I believe, 6 volts to 12 volts. And then there's a voltage regulator here that'll regulate the voltage back down to 3.3 volts and 5 volts. So again, that's an Arduino Uno. The other thing in this kit we're going to be using is a breadboard. And this is a breadboard. And what it does is it allows you to put wires into the pinholes and then connect the wires. So your power rails, I'll call these power rails on the top and bottom. Across the top and bottom, the negative is on the very top, and they're all connected in that row, and then the positive is the red, and that's all connected in that row for the entire length of the power rail. There's also another set of power rails on the bottom here, and again, same thing. The very bottom is connected, and the next column up is connected. Now on the breadboard itself, these rows of 5 pins each are connected. So every 5-pin row is connected with each other. So that one's connected, that one to that one to that one to that one, and it's isolated from the next one. So the next 5 holes, they're connected together this way, and so on and so forth. So as an example, say I put a jumper wire in there, and that's on number 31, and I put another jumper wire right aside of it on row 31. These 2 wires are now connected together and electrically connected, and then you'd run a circuit through that. Let me pull that out. Next thing we'll be working with is an LED. This is an LED, if you can see that. Let me lay this down that way. There you go. And an LED is just a light emitting diode. So you're going to get a light out here when you put power through it. The long leg, it does have polarity to it, so you have to put the positive and negative in the proper position. So the longer leg is your positive, which is also called the anode. Your shorter leg is the negative, or the cathode. How I remember it is the positive anode is PA. So we live in Pennsylvania, so PA is positive anode. That's an LED. The other thing we're going to use is a current limiting resistor. Now in our kits, we're using the Sparkfun kits, but this is going to be a 330 ohm resistor that's going to be in line. Now it has to be, when you're wiring a circuit, and I'll show you what circuit diagram is, you need that resistor to make an LED work. And the other things I already showed you too, but we're going to use jumper wires to complete our circuits. And those are there. Okay. Now let me show you the basic circuit that we're going to wire today. This is what a basic circuit diagram looks like. And we're going to wire a resistor in line with an LED and in line with our Arduino. So this plus side is going to be one of the pins along the output rail here. Again, input output, we're going to declare that's an output, and the output's going to come through, and that's going to be your positive voltage going through the resistor. Again, what the resistor does is it slows down the amperage going to the LED. If you didn't have that resistor in the circuit, there'd be so much amperage going through it that you'd burn out the LED in a heartbeat. So you do need a resistor in an LED circuit. And that's the LED symbol, and that's the light coming off of here. And then to complete the circuit, it has to come back down and go to the ground wire. And that completes the circuit. So it's one big circuit. The ground wire on the Arduino is right here. So the two pins here are ground. And I don't know if you can see that, but indicate you'll see that in the kit. But there's two pins here that are ground wires. And then that completes the circuit. All right, let's move this aside and we'll get the kit out again. Again, you want to make sure you're using kit number 1. And in our library system, kit number 1 is that. So let's pull the documentation out first. That's on the back. Now this lesson will be following the documentation that's in the kit, and then anything further we can always experiment with and expand upon. Now let's pull this Sparkfun Arduino out of the kit. We'll be using, actually all the components for our series of lessons will be from the Sparkfun Inventors kit. And it's a red board as opposed to the blue board that is an Arduino original there, or Arduino Uno. So it's the red board. It's a little different in that the processor is a right on the surface. It's an SMD processor built in the same. It's the same processor, just a different package. Also, the connector connector USB is a mini USB as opposed to a standard USB. Also on the board, you'll see 4 LEDs: the blue, green, yellow, and red. And you'll see your 330 ohm resistors here. And the circuit completes the circuit with these yellow wires that go to pin 13, 12, 11, and 10. So that's complete there. And then on your ground rail, this black wire goes to the ground rail of the breadboard, and then it connects to the ground of the Arduino, or Sparkfun Arduino, if you will. Now let's connect this up. And you can hear hear my computer recognize the connection to the Arduino there. And you get this in focus. There we go. And we'll leave that up here. Again, we're going to follow this lesson plan, and but we're going to type it in as we go. So hopefully, if you're having issues with seeing how it goes, we want to go check the documentation. So for instance, once we upload the code, if your LEDs don't flash, the circuit diagram is on page 5. Again, it shows your Arduino, shows your yellow wires going to the resistors, and then in line to your LEDs, and then ground wire back to the Arduino. So if your LEDs aren't flashing, you want to double check that on the documentation in the kit itself. Okay. Let's see. Make sure we didn't forget anything. Okay. Got it. Next thing we're going to do is we're going to open a programming environment. Now in your Chromebooks you're going to be using CodeBender. So when you plug your Arduino into the CodeBender, it should recognize the code. It should recognize the Arduino. I'll be using the Arduino IDE development environment as a programming platform. So I've just opened a new program here, and it has a void setup and void loop. What we're going to do is we're going to find an example program. Now, in the Arduino IDE, there are example programs. Let me find this basic blink program. In CodeBender, you will have the same program, as same type of example. It's called blink, and what it does is it blinks an LED. Let's go through what a program looks like first. So if you look at the top, anything inside quotes with slash marks, that's the documentation. Basically, it's the compiler will ignore that documentation. Anything inside those slash marks or documentation, again, the computer, when it compiles it, will ignore that. Same here, that's documentation. It just says what the void setup does. And it's very good coding practices to document everything that you do. So if you write a code, and for instance, if you write a code and you put it away for 6 months. 6 months later, you look at your code again. If you didn't remember what you did, you would have to rework that code all over again. But if you document the code, that way you know what you did, or you can remember what you did. Also, if other people are looking at your code, if you have it documented, they can help you troubleshoot or debug the code a little bit easier than what you had than if you didn't remember it. So this should be on the top here. You'll see a check mark, and what the check mark does is it compiles the code just to make sure there's no errors on the code itself. So it's compiling right now, and what compiling does is it takes your code and changes the machine language that the computer can understand. Let's wait for it for a second, let it compile to double check the code. Now again, it's an example program, so probably no issues there. And it's done compiling, and there's no errors. Everything is nice and blue. If it was errors, it would turn orange or red. CodeBender changes a little bit differently. If you have an error codes on CodeBender, it immediately gives you error messages at the bottom of the code and shows you what's going, gives you error messages and gives you what line the error message is at. So depending on whether you're using CodeBender or using the Arduino IDE, then it would be slightly different as far as troubleshooting goes. Now I uploaded the blink code, and you'll notice there's a blue LED flashing over here, and there's another blue LED flashing on the board itself, if you can see that. There you go. Arduino boards will have a built-in LED, and that's built in on pin number 13, has a resistor built in already as well. So when you're putting a blink program in, it'll show you that it's blinking on the board, and that basically tests the board. Now again, we've already wired another LED on pin 13 out in the breadboard here itself. Now let's experiment. On the code itself, it says built-in LED. The built-in LED is actually pin 13. So we're going to change that. We're going to change that to pin 12. And we're going to change it in a number of places here. And then I'm going to explain what each section does. What the code does, again, with this documentation on the top, this is where you would normally put your variables or your constants. So if you're when you're using variables and constants in the program, you have to declare those variables and constants so that the computer knows what you're talking about. The next section is called void setup. What void setup does is you're telling the computer what pins are being used and whether they're inputs or outputs. So where it says pin mode, it tells, in this case we're saying pin mode, pin number 12 is an output. In the void, and again we'll declare every pin that we use in each program. Now the void loop is the part of the program that we're going over and over and over again. So where it says digital write, we're telling the computer to write to pin 12, and we're going to write it high. So digital write, we're going to write it on pin 12, and we're going to write it high. What we're doing is we're telling that pin to go high, and high means 5 volts. So we're telling the pin to go to 5 volts, and when we put 5 volts into the circuit, it turns on the blue LED. So right now it's turning on the blue LED. Now what it's doing is delaying 1,000 milliseconds. So it's waiting a second, and then it goes to the next line. The next line says digital write. We were writing on, before I changed it, was the built-in pin, and we're changing it to low. When we're changing to low, we're turning the pin off. We're taking it to a low state. Low state is 0 voltage. When it goes to low state, the LED turns off. And I'm going to delay that by 1,000 milliseconds again, or 1 second. So what happens is it's going to turn your pin on high. It's going to wait 1 second, turn the pin off on low, and it's going to wait another second. So that's what's flashing on pin 13 right now on the breadboard itself. Now I changed it to pin 12, and we'll see what happens. I'm going to upload this program by changing the pin mode to pin number 12, and you'll notice on the circuit board itself, on the Arduino, you'll see these two LEDs flashing, and that tells us it's transmitting and receiving from our computer. Now what you notice, since I changed it to pin 12, the green LED is now flashing, the blue LED is off. So we've actually changed the pin to pin 12, and that changed the output to pin 12, and the output of pin 12 is the green LED. Let's change that to 11, just to see what happens. And we'll upload that again. And again, notice on this Arduino, you'll see the two LEDs flashing in the center here. That's transmit and receive. That tells us it's communicating with our computer and uploading the code. And you'll notice the yellow LED is now flashing, and that's on pin 11. Okay, and you can experiment with that, but what we're going to do now, the next section of I'm going to turn this off. There we go. The next section of the lesson is called Blink++. Now that's going to be a complete program where we are going to flash the LEDs in sequence. We're going to flash first one, turn it off, flash the second one, turn it off, flash a third one, turn it off, flash a fourth one, turn it off, and then we'll go back to number 1 again. But that is what we're going to try to program in the last section here. So let me open up another Arduino IDE, and we'll start that sketch. Now it does say in the documentation here, it tells you to modify it, but I'm going to write a new one. So I'm going to open a new IDE with no code on it. Get this to the right spot here, and then we'll start typing. Okay, I'm going to give myself some room on the top. And the reason I want to do that, I'm going to explain what I'm doing as I'm typing. So the very top section of the code is going to be for your global variables or constants. In this case, we're going to do constants. So CONT, INT is integer, and we're going to name that first pin LED blue. So we're naming that pin LED blue, and we're going to make that equal to pin 13. I'm going to put a semicolon behind that. Declare pin 13 as LED blue. So we've declared the constant LED blue on pin 13. And I'm going to do that. Now you can certainly do a variable. A variable would be without the constant in front, and it's LED green. Now what happens, the difference between a constant integer and just your standard variable integer is in your program itself you can actually change the green LED designation to something else midstream. So if you wanted to change it to something else in the program you can, but we're going to actually make these, we can declare this as LED green. We're going to actually make, I'm going to go to the front again here and change that to a constant. Okay. You also notice on our Arduino IDE, if you type the word correctly, it'll change color, and that helps in programming and try to avoid some errors. I'm going to declare constant LED yellow as pin 11, and I am going to be good and document what I'm doing. Pin 11 as LED yellow, and we'll do a constant integer LED red equal to pin 10, which is what's wired up on the Sparkfun Arduino. Declare pin 10 as LED red. Okay, we've identified the constants LED blue, LED green, LED yellow, LED red as pins 13, 12, 11, 10. Also, as I'm talking, you want to make sure you have a semicolon at the end of every line of code. If you don't, the computer won't know that you finished that line of code, and it'll continue reading the next one, and you'll get an error message if you don't do that. So be sure you have semicolons at the end of every line of code to tell the computer that you are done with that line of code. Void setup. This is where we're going to declare, we're going to tell the computer, you're going to tell the Arduino what each pin is going to do. So how you do that is called pin mode. So the pin mode, I typed it correctly, it turned orange. Code bender is going to be slightly different. And in our parentheses, we're going to put LED blue, and we're going to declare that pin as an output. And if I spell that right, it would look good. O-U-T-P-U-T, turned blue, looks good. And I'm going to I don't want to call it initialize. What would be the word? Well, we can call it declare again. Declare pin LED blue as output. There we go. And I spelled output wrong. There we go. Okay, I'm going to do that for every one of the pins that we are using. So, and again, I suggest that you type everything out at least the first time. You can, if you're good at copying and pasting, you can certainly do that. But for the first couple of programs that you're running, I would suggest that you type everything out. If you make a mistake in your program and you copy and paste it, you're going to multiply that mistake tenfold if you keep on copying and pasting. So again, I do suggest that you type your code out, at least the first couple of programs that you write or sketches that you write. And LED yellow, and we can declare that as output. Semicolon, declare pin LED yellow as output. Now again, your comment section really doesn't matter whether you're spelling it right or not, but I get a little anal about that, so I want to make sure it looks good. Spaces, we'll talk about spaces too. The computer, when it compiles, will ignore any spaces as it ignores the comment section when it's commented out. But we do put spaces in to make it readable. So if someone's trying to read your code and you have enough white spaces in your code, it makes it a little easier to read. Especially if you're asking for help from someone to help you debug your program. If you don't have any spaces and it's one big line, it might be hard to read and difficult to troubleshoot or debug. Okay, so that's the setup. We've declared every pin as output, and we've declared which pins that the LEDs are connected to. Your void loop program is where you would run code that repeats itself over and over again. And in the first program, it was basically turning pin 13 on, turning pin 13 off, and having a 1 second delay in between. So we're going to do that again. And the code is digital write. So we're writing to a pin, and we're going to write the pin LED blue. And we're going to tell the pin to go high. When we tell a pin to go high, we're telling the pin to turn on. Turning on means it goes from 0 to 5 volts. So it's actually turning it on to 5 volts. And we're going to delay 1,000 milliseconds. We're going to wait a second. We're going to leave it actually turned on high for a second, and then it reads the next line of code. Next line of code, we're going to write to that pin again. Digital write LED blue, and we're going to turn it low. When we turn it low, we're taking the state of that pin and we're changing it to low, which basically turns the LED off. Okay. And we're turning the blue LED pin to low or turning it off. Now, after we turn it off, we're going to delay another second here, just like the original program. So 1,000 milliseconds, and we're going to turn it off. So tell you what, before we all go on, let's compile this guy and see if it works. So actually uploading just the blue LED program. Even though we declared everything else, we can leave our loop program just on the blue. And wait for that to compile. Again, you want to look at your Arduino and take notice of the two LEDs right here. They'll start flashing when they're communicating with the computer. And it's flash, and it's doing what we asked it to do. It's flashing the blue LED on and off every second. Now, let's do it to the green. Tell you what, let's just call this flash green LED. All right. Now, I'm just putting a separation between my code. So, next part is we're going to flash the green LED on and off. Digital write LED green. I'm going to change that to high, close bracket, semicolon, and we'll do the same thing. Delay 1,000 milliseconds, and we're going to turn it off. Digital write LED green, and we're going to turn that off to the low state, and we're going to delay another 1,000 milliseconds. Let's do the rest of them. Oop, let me comment that out. Flash yellow LED. Digital write. Spelled that wrong. Here we go. LED green, what's after green? Yellow. Yellow, and we're going to turn that high, turn it on, close bracket, semicolon, delay 1000 milliseconds, oops, semicolon. We're going to leave it on for a second, and we're going to turn it off. Digital right LED red, and we're going to take that high, turn the red LED on, and we're going to leave that LED on for 1 second, 1000 milliseconds, and then we're going to turn, whoops, I got ahead of myself. Forgot turning the yellow off, so we're going to, I'm a little ahead of myself here. There we go. We're turning the yellow LED on, and we're turning the yellow LED off. Now we're going to do the red. Flash red LED. Okay, there we go. Got a little dyslexic there. Digital right. And this is LED red. We're going to take that high to a high state, which just turns it on. We're going to delay 1000 milliseconds, turn and leave it on for a second. Then we're going to turn it off. Digital right LED red, and we're going to make that low, semicolon, and delay 1000 seconds, semicolon. And the close bracket's down the bottom here. So I want to just explain the how the code works. Inside your void loop, you're going to have a void loop. Your conditionals are here. Since we're not going to put any conditions inside that bracket, so it's going to leave it blank. But the code itself starts with a curly bracket and ends with a curly bracket. So anything inside those curly brackets is your code for that void loop. Now, let's go through the code itself. We're going to digital right blue, and we're going to turn it on high. Wait a second. We're going to turn that blue one low. Wait a second. We're going to turn the green one high. Wait a second. Turn the green low. Wait a second. Turn the yellow one high. Wait a second. Yellow one low. Wait a second. Red high. Wait a second. And then red low. And wait a second. So that's what we want to do. We want to turn the blue one on, turn it off, turn the green one on, turn it off, turn the yellow one on, turn it off, turn the red one on, turn it off. Okay. Let's compile it. Tell you what, we're going to verify it. We're going to do the check mark, and you'll notice at the bottom here it's compiling, and compiling is done. So we're going to upload that. So it's going to compile it again, just to double check the program, and then it's going to upload it to our Arduino. And let's look on Arduino again, and notice the transmit receive. Just make sure it's actually already transmitted. So you'll notice on your LEDs, it's going to flash blue for a second, flash green second, turns off. Yellow on for a second, off for a second, red on for a second, off for a second. So the program is working without any errors. I think we got lucky. But that's the extent of what we're doing with lesson 1. Now, what you can do, experiment with this. You can experiment with the timing. You can turn your timing a little bit higher, a little bit lower. That's 1 second there. You can take it to 5 seconds. You can take it down as low as a half second. When you get down as low as a quarter second, it may look like a solid number, a solid LED. So there is a delay there. So like I said, 1 second is pretty visible. Half second is visible. Quarter second, it should still be visible. When you get down to like tenths of a second, then it might look like a solid LED, and that's okay too. When you vary the second delay, when you vary the delays, you can actually do a dimming, what looks like a dimming on the LED, or a higher power on the LED. The other thing you can do, I'm going to do some copying and pasting here just to do a demo. So say I highlighted the yellow LED. Whoops, let me go backwards here. Let me highlight this flash LED, and we're going to copy that, and we're going to give us some space and paste it there. So what I just did was the blue was still in the same spot, the green was still in the same spot, on and off. The yellow I have going on and off twice. So let's upload that and see what happens. And we'll go to the Arduino. You see it flash, you see it transmit. It's got blue, green, yellow, yellow, red. So it's doubling up on the yellow flashes when it gets there. Green, okay, which is essentially what we did. Now we can certainly do that again. Say we gave another line, we copy that again. So we have blue, green, yellow, 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 and red. So what we're looking for, at least what the program at this point says, it flashes yellow 3 times, while every other LED only flashes once. So I'm going to upload that and take a look, see if that works. And you'll see that double flash on the blue, blue, green, yellow, 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 red. Program, it does exactly what we expected it to do. And now again, we were lucky we didn't get any errors on it, but experiment with that. You can again experiment with the timing, experiment with multiple flashing, and that will get you more practice on typing and more understanding on what the program is actually doing. And that concludes our program. Let me turn this off for a second. On the last section of the lesson, again, it does suggest that you can change some of the aspects of the code itself. And then there are suggestions on other things to try. You can modify your delays, which again, that's what I said as far as the 1,000 or 1 second. You can change the constants, and you can change the timings on the LEDs. On the back section, the last page, is references on commands. Now this is when we start getting into the next section of coding. But this shows you what we went over today. We went over the integer constants, we went over the integer data types, pin modes, digital write, and delay. So that explains the codes more than we just showed. So basically, I just showed you the programming. If you feel the need to take a look at more detail on the codes, certainly reference those websites. And that concludes our basic LED programming. Thank you for watching, and tune back in for lesson 2. Thank you very much.